Hi everyone. In the last video, I just taught how we can identify the method for conversion. It is just my way, okay, so that I will remember in that way. So the same way I have taught you. Now we will see how to convert decimal number into binary. That is, in today's video, we are going to see how to convert a decimal number into binary. Similarly, decimal to octal and decimal to hexadecimal. These three conversions we are going to see. And here, decimal to binary. Decimal comes first, so it is division. So the question is convert 75 to the base 10 into binary. So because it is base 10, the 75 is a decimal number. So what is the method? Division. And with what number we should divide the 75? Abdina, it is to divide by 2. Because the base of binary is 2, that is the reason the method is repeated division by 2. Okay, so how can we do this repeated division? 75 to be divided by 2. Whenever we divide, we will get a quotient as well as a remainder. So write the quotient here and the remainder the other side. Okay. So whenever you write a quotient, immediately write the remainder. Okay. Because in the last step, few are missing to write the remainder. So that is the reason whenever you write the remainder, whenever you write the quotient, immediately write the remainder. So how to do this? The quotient will be 37 and the remainder is 1. Okay, again this 37 should be divided by 2. Repeated division but the 37 should be again divided by 2. Now it will be 1, 8, 18 and the remainder is again 1. This 18 to be divided by 2, 9 is the quotient and remainder is 0. Even if it is 0, write it as 0. The remainder to be written as it is. And 2, 4, remainder 1 and again this 4 divided by 2. 2 will be the quotient and remainder will be 0. Again 2, 1 will be the quotient and remainder is 0. Till the last step, the remainder is to be written. Okay. So here you can see, because the number is divided by 2, the possible remainders are 0 and 1. So now when we group the reminders from bottom to top, we will get the binary equivalent. Suppose if you are getting a remainder as 2 or any other number, you can think that it is wrong, because when you divide a number by 2, we don't get a remainder 2 or 3. Okay, the possible reminders are zeros and ones, and only that reminders we should get. And when we combine the reminders from bottom to top, that will give you the equivalent binary number. So here the equivalent binary number for 75 to the base 10 is equal to, start from here, group the reminders from bottom, 1, 0, 0, 1, 0, 1, 1 to the base 2. So this is the binary equivalent for the given decimal number. Okay, so this is the method. Sometimes you may get zeros everywhere, sometimes 1, anything, whatever the reminders, write as it is and group the reminders from bottom to top. So this is the method to convert a decimal number into binary using repeated division of 2 method. Now today's second conversion, convert 75 to the base 10 into octal. The same decimal number I am going to convert into octal. So here also decimal comes first, so it is division. With what number we should divide this 75? It is the base of octal, 8. Okay, so 75 to be divided by 8. Repeated division by 8 is the method. Now we will divide 75 to the base, divided by 8. So 9 times it is 72. The remainder will be 3. Again, this 9 can be divided by 8. We should proceed the division till we get a number lesser than 8. So when we get a quotient lesser than 8, we cannot proceed dividing the number with 8. So with that, we should stop. But now I have got 9. 9 is greater than 8. So I need to continue with dividing this number 9 by 8. So 1 is the quotient and 1 will be the remainder. So after this, I cannot proceed the division. I will stop with this. And again here also, we will group the reminders from bottom to top. And when a number is divided by 8, the possible reminders are 0 to 7. We will not get the remainder as 8. So when we group the reminders from bottom to top, the number what we are getting is the octal equivalent for this number 75. So you can write 75 to the base 10 is equal to 113. From bottom to top, we need to group the reminders, 113 to the base 8. Here also, if you are getting a reminder as 8 or 9, then it is wrong. You need to recheck it, because whenever it is normal max, whenever you divide a number with 8, you will not get the remainder as 8. Okay, 0 to 7 will be the remainder. So when we group the reminders, we will get the octal equivalent. Okay, so this is what the method. When a number is bigger number, you will have to proceed to 3 or 4 steps. So anyway, till you get a number lesser than 8, we need to continue dividing the number with 8. That is why the method is named as repeated division. Okay, repeated division by 8 is the method. Now, in this video, the next conversion is decimal to hexadecimal. Okay, 75 to the base 10 to be converted into hexadecimal. The base of hexadecimal is 16. Decimal comes first, so it is division. Repeated division by 16 is the method. Okay, now 75 to be divided by 16. 16 into 4, 64. So 4 times it is 64. The remainder will be 75 minus 64. It will be 11. So I should write the remainder as 11. Actually, in the previous methods also, each and every remainder, okay, is a digit. In the other number system, each and every remainder is a digit. So here also the same way, and after this 4, I cannot proceed to divide because this 4 is lesser than 16. I cannot proceed dividing this 4 by 16. I should stop with this. But as I told, each and every remainder is a digit in the other number system. So here we have got 11. 11 is not one digit, it is a combination of 1, 1. And we know that in hexadecimal, we have numbers from 0 to 9 and A to F. For capital A to be written instead of 10. So for 10, it is A, and for 11, it is B. And here we have got the remainder as 11. So you should not write by grouping the reminders from bottom to top again. We cannot write like this. 4 and 11. 11 is the remainder we have got here, and I cannot write the remainder 11 as it is. If I write like this, it is wrong because this 11 is not a digit. The reminders forms each and every digit. Each and every remainder forms a digit on the other number system. So here 4 is one digit. 11 cannot be written as a digit. So in this, we are supposed to write the equivalent alphabet to this 11. You can write the remainder as 11 here, but along with this 11, you write the alphabet, equivalent alphabet also. And here we are supposed to write like 75 to the base 10 is equal to 4b to the base 16. This is the correct format of writing the hexadecimal equivalent in this case. But when we get a remainder in single digit, no problem, you can write. Suppose if you are getting a remainder as 9, 8, you can write that as it is. But whenever we get a 2-digit remainder, and this is only in case of decimal to hexadecimal conversion. In the other two cases, you may not get this problem because when we divide a number by 2, we will get the possible reminders as 0 and 1. Similarly, when we divide a number by 8, we get reminders only from 0 to 7. But here we are dividing the number by 16. Because of that only, we are getting the reminders from 0 to 15. In that case, till 0 to 9 reminders, you can write as it is. And when you get a 2-digit reminder, write the 2-digit reminder as it is. But near that, write the equivalent. Write the alphabet, which is equivalent to that 2-digit number. So that when you group the reminders, the 2-digit reminder should not be taken. Instead, the alphabet, which is equivalent for the 2-digit number only, to be taken for combining the digits, combining the remainder. So this will be the equivalent hexadecimal number for 75. Okay, so only in this conversion you will have this confusion. No confusion at all. If it is a single digit remainder, write the remainder as it is. But when you get a 2-digit remainder, instead of 2-digit remainder, you should write the equivalent alphabet, and that equivalent alphabet only should be combined because 11 cannot be written as a single digit. It is a number with a combination of 1 and 1. So this is not correct. This way of writing the equivalent is only correct. Okay, so in today's class, I have taught you how to convert a decimal number into binary, octal and hexadecimal. Okay, hope you understood. Thank you.